As I already told Michael, this is a little bit improvised. I was supposed to give this last week, but then I was ill, so I could be paid. And in the meantime, I have done a bit of work, but still not as much as I would have liked to do. But I think it will be interesting. So what I'm trying to do here is for the first time to a research I've been busy with a late one on the origin of gold, right? One on the origin of consciousness, human consciousness. Okay. So what the two projects have in common is that they're both about agency, which is a topic I think that in your later you also have been thinking about. So agency, first of all, means goal-directedness, systems that are moving towards a goal. In order that they need to be able to make of the conditions in which then they should be able to make the right actions. That is the main theme, but then I want to go to a higher level of agency, the human consciousness, where you're not only acting reflexively, but you are able to choose between different courses of action, and that will allow me to put a first attempt tackling the so-called hard problem of consciousness. So that's briefly what I want to go out on. So let's start the first part, which is about a goal directedness, or actually about a life. So all living systems are there because they have survived natural selection. It means they have been selected to be fit. And to be fit, that means that they should be able to survive and to grow. If they are not capable to achieve that goal of surviving and growing, well, they simply are eliminated. So we can assume all living systems have this inbuilt of survival, and what survival, they can maintain their metabolism of perturbations because the world is not always the same. So this I will summarize as agency. Living systems have the implicit goal of wanting to survive, wanting to maintain themselves. In order to do that, they need to act. That means they need to be able to exploit opportunities of surpassing perturbation. And in order to act, they need to have some kind of implicit cognition, namely they need to know what action is appropriate for what perturbations. So that's the basic framework. Let's now go into more detail about how that could have evolved. So the best definition of living systems that I know is the famous one of Maturana and Autopoiesis. Autopoiesis means living system is self-building. It's a network of processes that reconstitute self. And Maturana and Varela automatically connect this notion of cognition to their notion of autopoiesis, because if the system should be able to produce itself, it should also be able to withstand any perturbations that may push it around this self-maintenance. So it needs to have this cognition. The theory of autopoiesis of Maturana and Varela is I would say really difficult, abstract, sometimes confusing. So I have tried to make a simpler version of it. That is a version where that is based on a network of processes, where processes then can be defined formally. An autopoietic system network of processes. What a process is something that some input transform that input into some output. So it produces new components, it consumes other components, or it transforms certain components into other components. And then the definition of autopoiesis is that the components being produced by these processes are such that they themselves generate the same processes that started them. So very simply put, the processes autopoietic system produce components, while the components produce the person. The whole thing is self-generating, self-producing. So to make that clear, I start from what I call a process ontology. That means I do not assume that the universe is constituted of objects, where objects are inert material things, which ultimately people tend to see as particles. I see the universe consisting out of process. And a process is something that we can described formally as action, a reaction, meaning you have some input things, they react with each other, and you get an output. And then a system, such as an autopoietic system, then becomes a stabilized network of processes. So instead of start on stable elements I assume that stability is the result of process that somehow stabilize. So what are reactions? A reaction is kind of like the minimal element of my ontology. A reaction assumes that there are conditions which are distinguishable states of affair. Condition can be the presence of a particular molecule, a part of biological species, but also be something much more abstract, a social condition of wealth or of a disease. Anything that can be distinguished from its absence is a condition. And then processes represented by arrows could be, for example, that a distinguishable condition appears, A is formed, a distinguishable condition disappears, a condition is transformed into a different condition, and some combination conditions react to form a combination of conditions. So this is a kind of formalism that is very similar to the one using T or in elementary particles, but the A, B, C, Ds that I write here, they can be any distinguishable conditions. So what's an elementary autopoietic system? It's a system that produces itself, but of course it must be thermodynamically open. That means it must have input from outside, and there will be some dissipation, be some waste. So in this case, I need to have some input of A, some output of B, and then A and B themselves. Now that's of course much too simple to have a living system. So let's look at a somewhat more complicated example. A complicated example in the sense that I have still an input, I still have an output, but in between I have a network of reaction that's much more complicated, but that is such that everything, every component, we condition, the base, the cities, there is always something produces it. Nothing appears, it disappears, nothing out of nothing. Everything is produced by some reaction, and the whole reaction thing is keeping itself going. So for those who are interested, this kind of mathematical model is called the chemical organization. There is something called chemical organization theory, in which you can look at the conditions on which a network of reactions becomes autopoietic, meaning self-meaning and closed. That whatever is consumed is produced, whatever is produced is consumed. So now, where does autopoiesis come from? That's kind of the assumption of my ontology, that is that processes self-organize into more complicated organizations. So how I have that in the simplest case. I start with the random reactions. Random that means any A plus B, C plus D's. We have experiments with that. We have just generated random networks, and then we have seen what happens is typically that it self-organizes into something kind of autopoietic. How does that happen? You start with number of components that are available, components or conditions. You have the reactions. The reactions transform the components into new components, which themselves are transformed into new components, and so on. When you start with a number of components, you produce some. You add the new one up to the point that you can no longer ones because there is no material available to add anything there yet. On the other hand, some of them are consumed, but they are not produced or not produced enough to keep the whole thing going. So you remove them. In the end, what are you left with? With components that are being produced, that are being consumed, but such that they are being put and consumed at the same time. So this is a formalism that I'm now sketching very quickly. For those interested, you can look at my papers, chemical organization, Autopoiesis. What is that a self-maintained network of reactions is an attractor of the dynamics. That means that if you let the dynamics run on its own, eventually you will get something that resembles an autopoietic system. Now, in most cases, the autopoietic system will be trivial, but in principle, you can generate an autopoietic system like that through self-organization. Now, what one thing to get to is that the autopoietic system should not maintain itself in ideal circumstances. That means ideal circumstances where all the input components are always there, but in the sense of a natural environment where things are not always available. Sometimes there are conditions that are interfering with your reactions. Sometimes the conditions you need for your reactions are not there. So I've said that the autopoietic regime is an actor, but there will be perturbations that will be pushing the system out of its attractor. So if we think about the autopoietic system as a kind of a very primitive living organism, that organ lacks food. So if at the moment there's not enough components, it will die. On the other hand, it may die because of toxin. That means components that interfere with the reactions that are necessary to keep the whole thing alive. So first stage is the system self-organizes into something self-maintaining. Second stage, that self-maintaining system being thrown around by perturbants. Most of them are killed off by perturbations, but eventually we may assume evolution will lead to an system that's resilient. Resilient, that means that it is able to bounce back from these perturbations, that there are all kinds of changes happening in the environment. It can somehow compensate for these perturbations. That means, for example, some components appear that previously worked as toxins, that means they are perturbing the metabolism. Newer version of the autopoietic system, the more resilient, will have some way to neutralize these toxins. If, for example, the food is not available, maybe it will have developed some internal reactions to digest a different type of food. So I'm assuming that if the process of evolution goes on long enough, the system will become more and more resilient. We have done a number of simulations with these networks, and indeed you see that if you give it enough time, it tends to become resilient. So what does it mean, resilient, in terms of dynamic systems? It means that the autopoietic system is an attractor. Its basic of attack means all the actions that lead to the attractor become extended. It will become wider. It will have a wider range of viability. So let's imagine this. The dark green that you see is the attractor. That means that is the autopoietic regime, which the system tries to turn. The light green is the base. That means all of the different configurations from which the autopoietic system can back to its regime of sustenance. A perturbation then means any unregulated change that makes the system move from one position to another. As long as the perturbations remain inside the basin, they will automatically be compensated, because as long as the system is in the basin, it will on its own go to the attractor. If, on the other hand, perturbation pushes the system outside of the basin, then it will no longer go to the attractor, which means that basically that autopoietic system no longer autopoietic cannot maintain itself. What could potentially happen is also a different attractor potentially could be even better. Let's not discuss that here. So that allows me now to define goal-directedness as resilient autopoiesis. Autopoiesis is the attractor. Resilient autopoiesis means if you perturb it from the attractor, if you push it out of the attractor, it will come back. It has a wide basin, and basin is an ongoing process of self-maintenance. So it's not an equilibrium like a thermal system goes to thermodynamic equilibrium. That is not a living system. A living system is a process that is actively self-maintaining, that is consuming and producing. So operation, what does that mean? A goal-directed system. If it's not in goal, it will move towards the goal. If it's in the goal, it will stay in goal. If it's perturbed, that means if it's pushed out of its goal, it will perform action that requires energy so as to return goal. So that we might kind of a minimal definition of goalness in living systems, a basic form of A. Now we come to the issue of cognition. So goal-directed activity, we can say, requires a minimum form of cognition because it needs to be able to compensate deviations from the goal. So if we look from the inside autopoietic system, it undergoes a deviation. It should somehow do sense that there is a deviation. That means it needs some ability of something. And it should also have an ability to perform an action. That means one of its repertoire of reactions should switch on so as to neutralize the deviation. And implicit in this whole dynamics is the notion of knowledge, namely action that's triggered by the sense condition should be appropriate for that condition. So the system should somehow know which action to perform for which condition. And that now model with additional form that is used in AI, action rules, condition rules. You have an agent. The agent has a number of condition action rules. That means the agent recognizes a certain condition. For example, it senses that there is condition X, and it knows if I'm in condition X, then I should perform action Y. And we can represent simply as a process X to Y. That process, one of the processes inside this complex net of processes that is poietic system. Now, cognition, there are lots of definitions of cognition, and we need to be careful about what we mean by cognition. So one of the more interesting results from cybernetics is so-called the law of regulatory models proposed by Conant and Ashby. And it says that if you want to have a goal-directed system, that goal-directed system must include some kind of mapping, which they call a model. Namely, it should map all the potential perturbations, the right action. That means for each deviation, there should be one specific action. That mapping exists, then the system is able to control, to reach goal, and that model, we might say, implement the system's knowledge. Now, model is a common term when thinking about cognition. The system has a model of its environment, but that is not the way that Maturana and Varela interpret it. Varela and Varela emphasize that what Conant and Ashby call is not a representation of the environment. What they say is the autopoietic system is autonomous. It functions internal. It does not know what is going on in the external world. The only thing that it can know is the deviations it senses. It has a metabolism, it has a network of processes. When one of these processes is not functioning the way it should be, the whole poietic system is perturbed, senses that there is something wrong, but it does not know what caused the deviation. So Maturana emphasizes that this kind of knowledge is subjective. The autopoietic system knows only the things that affect its own autopoiesis. It does not represent the environment in some objective way. So now we come to the further evolution. So we already have a system that is autonomous, that is goal-directed, that has some level of cognition, but we can think this cognition should extend the system, be able to adapt to these conditions, and lots of, if there's a lot of variation in the environment, the conditions will change. So that means the system should be able to sense the conditions, should be able to interpret the conditions, it should be able to make sense of the conditions that it senses. So it requires that it has some elementary awareness, not really of what objectively going on in the environment, but in what ways are changing in the environment so that it affects the system itself. So we let evolution play its role. The system will need to become more aware, more and more intelligent, so that it can recognize a wider range of conditions and can interpret them and perform the right types of actions. So now this is a scheme that you probably have seen, which I borrowed from Michael. He called the cognitive, I believe. I have called it the cone of awareness. So if I have an agent that is situated somewhere in the middle of that cone, the agent will to some extent be aware of what is going on in its environment from this purely subjective point of view, but still it will to some degree be aware of conditions in the past, in the future, in the neighborhood. So the cone kind of represents the range of awareness, the kind of range of that the system potentially makes sense of. The more advanced the system, the wider the cone. So here is another picture that I took from Michael. Here are some examples of cones. A very small creature like a tick will have a very small cone. A human can have a very big cone, and a dog can have something in between. But now I make a very big jump. I started by explaining autopoiesis, which is the organization of a single, like a bacterium. And now I'm making a jump in human consciousness. So let's forget about all the intermediate stages, multicellularity, animals, nervous systems, etc. But what is the essence of the difference between the cognition of a bacterium and the cognition of human? Well, in bacteria, the way I describe the cognition is deterministic. The bacterium senses a particular condition, performs a particular act. Always the same. The condition leads to the same action. Now we're speaking about higher organisms, and we humans are there, but probably others, probably apes, dolphins, and other mammals, and maybe birds are also there. But there is an intermediate decision-making stage. That means there is a condition that the organism senses, and then there is a stage that here I have called reflection of considering different possible ways of reacting to that condition. Means that the action follows a process of reflection, and actually there is no action, I make some of the conditioning with them, and I can decide I need to act in this way, or I can decide there is no action worth taking. So this is what's called free will. We humans have the ability to consider many different causes of it and to choose one of them. And that is typically what we will call conscious, this ability of considering different possibilities. Now, to define conscious, it's easiest to distinguish conscious from subconsciousness. So we humans still have the same level of subconscious reactions like bacteria and like simple organisms. We have this kind of automatic involuntary reflex. For example, if I put my hand on a hot stove, I will pull it away immediately. I don't need to think about what this stove is hot. If my hand on it, then it will burn. Therefore, I should pull away I will just pull away my, and I may not even feel the heat of the stove. So that kind of process implemented in the brain, it's modeled as what is called a feed-forward process. It's a process that goes straight from sense condition to action. There's straight, immediate way. There are no detours. Now, what's the difference with the conscious process? A conscious process is a process that we can monitor. We can in our own mind, we know what we are thinking. We can examine our thoughts, also redirect our thoughts. For example, I may distracted and tell myself, no, you should be busy with that, you should be doing that. So conscious processes are processes I define as processes in the mind that can be monitored, that can be examined, and that can be redirected. Of all the many different theories of consciousness, the one that I like the most, the one that I think explain this is also most concrete, is so-called global neuronal workspace theory. The most active research is Stanislas Heylighen. What the global neuronal workspace model says is that there is some kind of a special network, the workspace, which functions a bit like a kind of a forum or a meeting space where lots of different processes coming from different parts of the brain come together. And a process in that workspace, they are what I will circulate. The Heylighen use the term reverberation. Other people call it or recurrence, resonance. But the main idea is it's a process that's a forward process. That means a process that goes in one direction. It's a process that cycles around. And what is the reason for the cycling? Problem with activation of neurons in the brain is that activation passed on. Neurons do not remain activated. So if you want to keep some in your working memory, you need to recreate the activation, and you can only by having the activation come back to the sense. And then that, for me now, the essence of what creates the consciousness, by keeping this thought or this perception active in your memory, you can inspect it. And if you can inspect it, that means that other parts of the brain can look at it. This other part of the brain intervene in, and is now what will create a free will. So I will it's best explained with drawing. So this is the scheme for the conscious processing, the feed-forward propagation. So what you have is just a line. The sensors sense some condition. There are a number of immediate neural modules that process information. For example, if I see something, there are different layers in my visual cortex that will first recognize light and dark, and then they'll recognize edges, and then they will recognize shapes, and then they recognize objects. It leads to a particular conclusion. In the example I gave of the hand on a hot stove, here probably it may not even reach the brain, it may just go to the spinal cord, but the sensors send the signal that eventually make me pull away my hand. It's just a thought process. So now processing, that is what I call circuiting activation. We have the sensors here on the bottom left, the sensor provide input. The effectors, my muscles, are output of the system, but before it reaches the effectors, the activation circulates in what's called the global workspace, which is some kind of assumed to be a network of long-range connections in the cortex. And then you have the different modules, which are specialized circuits that, for example, recognize sounds or look up links or make equations or fractions. The modules can be very diverse, very specialized, but these modules now interact with what's going on in the workspace. That means that what happens in the workspace, the activation that's circulating, can go to one of the modules, which the module doesn't do anything with it. On the other hand, it can go to a module reacts to it, an interaction, or there can be a module that receives information from a different part of the brain and that sends input in global workspace. So global workspace is seen as a kind of a forum, a kind of a public for all these specialized brain circuits enter in a kind of a discussion. It's as if they are talking together in this global workspace. So here there are some examples from the HANA, where they have been doing experiments with monkeys, and you can give the so-called subliminals. That means something that a visual stimulus that appears and disappears so quickly that the monkey doesn't have time conscious of it, and you see this kind of a feed activity. That means that for the input, the neurons get directly activated and they pass on their output to a number of neurons, but it moves basically in one direction. On the other hand, if you leave the stimulus for a long enough time that the monkey becomes conscious of it, now that's what they call reverberation, what I call circulation. Now you see that the different created neurons, they send radiation back and forth. The thing is keeping itself activated. That is a standard model of consciousness, or what is called access consciousness. The consciousness in the sense that you have access to what's going on in your mind. You have the ability to examine, to monitor, to redirect whatever is going on in your mind. But now there is another aspect of consciousness that is subjective experience and is associated with the so-called problem of consciousness. What is a subjective experience? It is a feeling that is something that you are conscious, and that subjective experience. I personally prefer the term subjective experience, but some other terms you may have heard are qualia. A qualia is an individual subjective experience. It's also called phenomenal consciousness, and a most common phrase define what a qualia or a subjective experience. That what is it like to, for example, what is it to see redness? Typical example, philosophy is redness is subjective experience. Is something else. as an input, but you have the subjective experience of redness. So the hard problem of consciousness is what precisely are these subjective experiences? Why do we have these subjective experiences? And the famous thought experiment that kind of defined the whole hard problem of consciousness was discussed by the philosopher David Chalmers. It's the zombie thought experiment. So what he does, David Chalmers, he thinks that there are certain creatures he calls zombies that behave just like any normal being, but they don't have subjective experience. So he imagines that the zombie would put his hand on a hot stove and the zombie would pull away his hand. And ask the zombie what happens. The zombie will tell you, I felt pain, but actually the zombie didn't feel anything. So the thought experiment is that the zombie behaves like a normal human being, but actually he doesn't have subjective experience. And then the hard problem is, since by definition we cannot between a zombie and a human being, we cannot do a scientific experiment that would explain what the human being has subjective experience, what the zombie likes. But yeah, to me that is a meaningless thought experiment, because if there is really no way that I can distinguish zombie from a human being, and all of you can be zombies, or none of you can be zombies, any of you can be a zombie. To me, that is not a good way to define it. So let's explain subjective from my point of view. First question, a question that philosophers, to my surprise, have a lot of difficulties with. Why is experience subjective? Why can't people just objectively see the way things are? So for me, it's obvious. Humans are autopoietic systems. Autopoietic systems, as I said, cannot objectively perceive the world. They do have access to opt out in the world. They only have access to the perturbs their self-maintaining processes, whatever interferes with their metabolism. If something interferes with my metabolism, that means, for example, that it leads to the release of neurotransmitters in particular cells, then I can feel that perturbation of my metabolism, but I do not have access to the thing itself. The thing that follows from my theory of poiesis is that autopoietic processes, by definition, they are not neutral. They care about what happens to them. They distinguish between good things and bad things. Whatever helps them to maintain themselves, such as food, they see as positive. Whatever interferes the autopoiesis, such as a plate that can burn them, they will see as negative. So from an autopoietic point of view, all experience, of course, happen from an internal first-person perspective. I can only perceive the world from inside my own body, inside my own brain. And what I perceive is neutral, is not objective. It is colored by my goals, which is to stay alive. And that is why, for example, I have a different perception between, let's say, a butterfly and a wasp. I like butterflies. I don't like wasps. I know that wasps can sting me, which will interfere with autopoiesis. So, as biology might say, you should be objective. Butterflies, wasps are just insects, but I'm likely to kill the wasp and not the butterfly. So now, so the subjective experience affects my autopoietic process. So what does that mean, affect? I'm using affect now in the psychological sense. an effect is something that acts on organ. That means it pushes or pulls me towards a thing. Like, for example, if there is food, I will be attracted to the food. On the other hand, it will push me away from things are dangerous, from disturbances. It will push me away from the hot plate or from the wasp. And that is typical of all goal-directed systems. There is a classic example of bacterial chemotaxis. Bacteria can sense food molecules and toxin molecules, and they are to follow a gradient towards the food or away from the toxins. So that's what we define elementary agency, elementary goal-directedness. Bacteria are affected by what happened in the environment. Effect there, but there is not that conscious effect. So now I finally come to my solution of the hard problem of consciousness. It's what I call local field model. I have also did the local prospect model. So effects are equivalent to forces, things that push or pull. On the other hand, consciousness tells me that I don't just immediately react, take the time to consider our different processes that push and pull in different directions. So there is a range of potential actions. Now, a range is something like a space. If I put a force across a range, I get what in mathematics or in physics called a field. I could represent it as a kind of a vector field across a space of potentiality. Potentiality, that means potential reactions I could have of it. But since I do not know what one under all circumstances, there is this cognition. The field is low, it emanates from the here now, and the farther away in space or time, the less my idea will be of what the field is. So how can we in this local field in the brain? I go back to my picture of the global workspace. There is a circulating activation. So in the global workspace there is this very activation, but the activation to some degree it's a process spanning activation in psychology. Things that are associated, that are related to the things that are in the global workspace will receive some leaking activation, and that leaking activation in a sense paves the way for potentially the next action or the next thought or the next interpretation. So the diffusing activation, diffusing from the global workspace, that in a sense forms the local cost, which to me is the subjective experience. We'll skip that one. So this local field, it's a conceptual model. The reason that nowadays I prefer to call it local prospect is that the first time I started explaining it to people working in consciousness, everybody kind of assumed that I was imagining some kind of a quantum mechanical field emanating from my brain, and the field is purely a mathematical concept or a conceptual model. It's not a physical field. On the other hand, I'm using field because field is something you can explain in mathematics. So that means that potentially I hope that there will eventually be able to make a mathematical model or computer model of what the subjective experience would be. So in consciousness, we speak about so-called neural correlates of consciousness. The subjective experience that you feel, the neural correlate, the activity that is objectively noticeable in the brain. And this neural correlate, for me, it's a term that I took from the neural networks Stephen Gosberg. I call it an adaptive resonance. Resonance because it is kind of self-maintaining circulation of activity. adaptive because it constantly adapts to things, to inputs and outputs. So there's activation that is kind of self-maintaining within work memory in the global workspace. That activation in and out of the resonance like that, it moves in one direction, action or the other. And initially the activation can do the different actions, and then it chooses action rather than the other potential. It's a little bit comparable to the collapse of the wave function in quantum mechanics. If your field of activation is diffusing, can be seen as a wave, then at a certain moment when you make a decision to do this or that, it's like the wave it, but then immediately afterward it starts spreading again. So free will, I see brain as a collective specialized modules. These specialized modules or circuits, we can see them as kind of agents within the society of mind. These agents interact, they have a discussion. The discussion takes place in this global workspace. And why is the will free? Because you can say beforehand what the outcome of discussion will be. It's as if you different people with different opinions and different backgrounds to think about whatever political problem. You do not know beforehand what solution they will come out with, because they are confronted with perspectives that have not been confronted before, and each speaks in turn. That means there is a very strong effect of who speaks when, timing, strength, etc. You cannot predict what discussion will be. It's a non-linear process. That means that it's still subject to what's called the butterfly effect, meaning that very differences in activation or timing can lead to these outcomes. In other words, the whole process is unpredictable. Why we call it free will. It is not deterministic. So again, the same picture, the society of mind now. Now we look at the modules as if they are agents. Each agent has certain opinions, certain things that it considers important, certain things it knows, certain things it's good at, and that agent is putting some of its opinion in the workspace, is where other agents can react to it, and their opinion to it. The whole thing is variegated in interaction, different agencies. So here I go back to the picture I took from Michael, where he speaks about compound intelligences. Cells together have a higher level of intelligent cognition than individual cells, because they interact, because they are in this kind of discussion. The same thing for organisms like ants, same for humans. At each level we can set cognition is collective. So the moment are different agents that become coupled, that means that they are in some relationship that's relatively stable. I know that they will exchange information because one will react what the other one does. The output of the one becomes the input of the other, and vice versa. Signals travel from agent to agent, and that allows a more distinct or collective intelligence. My first example was a bacterial cell, autopoietic network that consists of actions. Each of the molecules is, you might say, a very primitive that is interacting with all the others. Together they form an autopoietic network. When I look at the human brain, the agents are different models that are holding their discussion in the global workspace. And finally, in society, we might say different people are discussing in what we call the noosphere, the World Wide Web, the general sphere in which communications are. Finally, inclusion. What I like to do is to a kind of a natural history of agency, starting from the very simplest agents, which are the outcome of reaction networks that self-organize. These reaction networks tend to become closed and self-containing, meaning that they are autopoietic. As simple autopoietic systems are undergoing perturbations, they need to learn to adapt. That means they need to learn to condition action rules. You know, in these conditions, I need to perform this action to survive. And in human brains, we have the additional stage of consciousness. That means that the conditioned action rules are no longer automatic, condition automatically leading to action, but we will get an intermediate stage of circulation where activated thoughts, feelings are circulating in what's called the global neuronal workspace. That circulation defines a local prospect of potential developments. Out of these potential developments, eventually was chosen, and the one that is chosen collectively, collaboratively by the different modules are discussing. So I think we still have time for a few questions.
Great, thank you. Any questions?
Sure, I'll ask a question. This is Chris. Thanks for your talk. You characterize the environment as a source of perturbations, and you also mentioned that autopoiesis is an attractor in the state space of a complex system. So do you consider the environment to be itself an autopoietic system?
That's an interesting question. This is part of a broader perspective, which I call relational agency. If you look at an ecosystem, you can see the system as a whole, as a poietic system, in the sense that there are flows of process being consumed and produced. So an ecosystem as a whole would also be an autopoietic system in that sense.
Okay, great. Thank you.
Anyone else?
Hi, I do have a question. Could you elaborate a little bit about your response to the zombie criticism? Or are you thinking that a zombie autopoietic system cannot exist? Or what exactly are your thoughts there? Just curious.
Okay, it's a kind of a metaphysical assumption which lightens the identity of the indistinguishables. So what he meant by that is, if you cannot distinguish two things, if there is no, you can say, I have a zombie here and I have a human here, and I can distinguish the one from the other some way, then the identity of the distinction says zombies are humans. So for me, postulating a distinction lead to any other distinction is meaningless. Yes. Another way to formulate it is something called the difference that makes it. If you start by postulating a difference between zombies and humans, then it should make some other difference. Just postulating a difference that does not lead to any difference, to me, is useless. It's making things complicated that shouldn't be made complicated. So the main question really for me is why do we subjective experience? Why do we something, for example, if we look at that and we feel, because the color red is a signal that has certain meaning for us, that we have associated, for example, with warmth or with passion, and that makes us do certain things rather than others. So the color red will influence me in a different way than the color blue, and that is what the subjective experience is.
Yeah, the way I always understood the zombie criticism was that subjective experiences it's not necessary to do the kind of things that like organisms as complex as humans can do. But we do have subjective experience, which it may have been a product of evolution, and maybe it plays a role